Okay, so a little bit of review from last class. So here we're given sort of like an equation. Calculate the output given an input. So the input is 0. What's our output? Negative 2. Right? Because 5 times 0, 0 minus 2 is negative 2. What about when the input's 1?
3.
And the input's 2? 13 and 17. 18. Right? So just plug in input into our equation, so 5 times whatever input is, and the result of that we just subtract 2. So calculating our first differences.
5.
What's the first one?
5.
3 minus a negative 2. I encourage you to use this because once we get in the negative numbers as our output, a lot of us get confused. I saw that on the online quiz when straightforward question, what's the first differences? A lot of people got that wrong. Just mixed up the negative 1 and the 1. Okay, so write it out. So we get 5, here's 8 minus 3, 13 minus 8, and 18 minus 13. Okay, so I could take this equation, or sort of formula, I could rewrite it as an equation. So instead of calling our input, we're going to just call it x, because that's like our independent variable, and output we'll call it y. So here we just get y is equal to 5x minus 2. Okay, so we're shooting again a relationship between x and y. X is sort of affecting what the output of y is. Okay, what are some similarities that we've noticed between what we have in our table and our equation? What are some of the similarities that you see? Touched on it last class briefly. Well, one of them in depth, the other one briefly. So there are two relationships that we see in our table and our equation. What is one of them? Look, don't look at me. Look at the table. What are some of the connections that we see, or some of the similarities? Abby?
The output when the input's 0 is like the end of the.
So you see that, sorry, you got negative 2?
Yeah.
This? Right? So when x is 0, we have output of negative 2, and you saw that this was the same as this?
Yeah.
Good. And what special name did we give this?
Y-Intercept.
Good. Y-intercept because basically the y-axis is when x is equal to 0. So that's what's going to cross that line. Okay. So here we can sort of decipher that this is a y-intercept. Good. Another thing that we see from our table, and it's similar between our table and our equation. So third, Andrew. All right. Similarity between our table, so the stuff that would come up on our table and our equation. What is it that we see?
The first difference is 5, and so is the slope.
Good. So here we saw that the first difference, we're all 5, it's constant, and that happened to match this value here. And what did you call it? So we found that the first difference, this is equal to slope. right,
That's if it's linear.
is equal to rate of change.
Only if it's linear. Only if it's linear.
Only if it's linear. And here we prove that it's linear.
Well, technically,
Technically,
even if it wasn't linear, it would just be the slope of each individual line.
no.
It wouldn't.
That's when you get the calculus. Grade 12 stuff. When you talk about slopes of nonlinear equations. Okay? So what was the special variable that we assigned slope? M. Okay? So what we recognize here is that in any equation, linear equation, we get y is equal to x, right? Some sort of relationship between x and y. We give it, plug in x, get a certain value for y. That's what we're plotting on our graphs, right? That's what that line represents. We plug in a certain value for x. That's what we got for y, right? So here, we see, well, that relationship, how it grows, is depending on our slope, or our first difference. What we do is introduce a special name for this. Okay? So some of you have heard y is equal to mx, so we got m from slope. B is really that value of the y-intercept. The value of the y-intercept. What is the value of y when x is 0? And that defines our equation. Okay? So that's how you get your equation of a line. Okay? Take one, pass it around. So one or two there. Can you just take one, pass it around, please? So this is what we're going to be talking about for the next little while, is equations of a line. Everybody got one? Okay. So when you have an equation, y equals mx plus 3, we call this the slope-intercept form. Okay? Because in this one form of the equation, we're both given the slope and the intercept straight from the equation. Okay? So here, the slope is m, and the y-intercept is b. Okay? So knowing that once we have an equation of this form, it's kind of easy to graph. So in this equation, first of all, before we could graph a line, we need two things. We need 2 points, or we need a point in the slope. Right? If I just give you a slope, can you draw the line? No. Maybe the slope is 5. Infinite amount of lines, slope of 5. If I give you a y-intercept -2, can you draw a line? No, it's just a point. Tons of infinite amount of lines go through that one point. So you need a combination of a line and a slope, or 2 points that give us that straight line. So here, in this equation, what are we given?
The slope and the
Slope and a point, right? Slope and a point, which happens to be y-intercept. Which one are we going to start off with to draw our line? Point. Yeah, you have to start off with your point. You can't start off with slope, because slope is always relative to another point. So here, what's the point that we can have?
0, 3.
So here the y-intercept is 0, 3. Right, so we go on to here, we plot it, 0, 3 would be there. Right, so graph this. And here, what's our slope?
-1.
Well, slope is what?
-1/2.
-1/2. So that's the same as, remember, our delta y over delta x. Which is the same as rise over run. Right? All those things. So here, to get our next point from this one, we're going to go up or down? Up. Down.
Down.
I don't know, it's up to you.
Up.
Where are you going to put the negative with?
With the 1.
Usually I like to put it the first one, the numerator, right? So negative 1, we're going to go up or down because it's negative. We're going to go down 1, and our run is what? So over 2, and that'll give us our next point. I can continue down 1, over 2, down 1, over 2. And then we get a straight line. Okay. What did I put at the end of my line? Okay. We need to see these. What does those arrowheads demonstrate? Veronica? Yeah, like it doesn't stop. Even though we physically stopped it, it could go on and on forever. Okay, so we need to demonstrate that with arrowheads. Okay, not bad. Pretty straightforward. What about the next one? Y is equal to negative 4.
We can't plot, we can't write that.
Just do this one in the middle.
We can't.
First of all, is this in slope-intercept form? No.
Yes, this is so intercept. It
It's
doesn't
like-
give us anything else.
If the slope is 0, then you can go to 0, negative 4, and have horizontal
Well, we know that any line, yeah, it's going to be of this form. So here, well, the plus b is minus 4, right? The one without the variable. Well, what's really the value of x?
0.
0. So what does that mean?
That's just no.
Well, first of all, what's my y-intercept?
Negative 4.
Negative 4. So let's plot that. We're doing this in blue. So negative 4 is here. I should really put a scale on here.
0.
This is my x and this is my y. So make sure you do that on your graphs. Put a scale, maybe x and y axes. So here's my y-intercept for this one. Y-intercept is negative 4. So my slope is 0. What's 0 mean?
You can go
Well, is there a rise?
No.
No, so it's just a horizontal line. So in other words, no matter what the value of x is, x could be 1 quadrillion. The value of y is what? Negative 4. So in this case, x is not affecting the value of y really. No matter what x is, y is negative 4. Okay, this one is a little bit more tricky. X is equal to 5.
We don't have a y. It's like we have a point.
We don't have a y. That's what makes it tricky. Right? What we have is a definition of a vertical line. Y is not 0. What we have here is, I'll do this in green. So here we have x where x is 5. Okay? Basically, this is a vertical line that defines x is equal to 5. All the places where x is equal to 5. It's just a vertical line. Do we have a y-intercept here? Will this line ever cross the y-axis? No. So this is a different way. It doesn't quite fit into the y equals mx plus b form, but you need to know it. If it's a vertical line, so it's infinite or undefined slope, right? It's just an x value. Find that value of x and draw a vertical line. Do you have a question, Michael? Finally, this last one. This is my y-intercept.
-6.
y-intercept. -6, so it's down here, 2, 4, -6. And what's the slope on this one? 3. What's my rise and run then? I've only got an integer. Yeah, so convert that into a fraction or a ratio. So this is my delta y over delta x. So here I'm going up 3 over 1, up 3 over 1. I could go down 3 to the left 1 as well, right? And here I got my vertical line, on my straight line. Any questions on this? So now I'm giving you an equation that's in slope y-intercept form. We should kind of graph it. Let's try to go the other way. Now we have lines. Can you give me an equation for this? Well, line 1. Line 1 is this one. Well, first of all, is it a horizontal or vertical line? Is it a horizontal or vertical line? Line 1. Does it go straight up or straight across? No. So we're going to have y is equal to something x plus b. We're going to figure out what those two things are. Which one we want to do first? Does it matter which one we do first here?
No.
Yeah.
Y-intercept.
Y-intercept first? I like y-intercept first because I picked that one off the easiest. So here, what's the y-intercept? Assuming that this had a scale.
4.
Right, is it positive or negative?
Positive.
Positive. So plus 4. And what's my slope?
3 over 4. That has to. I think it's just negative.
Well, I'm gonna pick.
4 over 5.
I'm gonna pick this point here, and then go up to this point.
4.
So go up 1, 2, 3, 4, and across 1, 2, 3, 4, 5. So it looks like it's 4/5. And that's our equation.
Wait, if they don't give us points, do we just make whatever point we want?
Just find the best that you could that intersects at like an integer, right on our property, so that's where it crosses the integers. That makes it easier to calculate your slope. So line 2, is that a horizontal or vertical line? Vertical. So if it's a vertical line, it's going to look something like x is equal to something. Here, what's that vertical line then? What's x equal to?
8.
So x is equal to 8. If I continue here, 5, 6, 7, 8, yeah. Okay, line 3.
It's horizontal.
It's horizontal. So we still have y is equal to. So y is equal to, is this one going to have a slope?
No.
Well, it does, it shows 0.
0x.
So we're not going to write it. In other words, what's our y value constantly?
7.
5, 6, 7. Y is equal to 7.
Y is equal to y.
Alright. That was a test.
If I'm not y is equal to 0x plus 7, what's the next?
You will lose what we call technical marks. Right? I mean, technically you're correct, but that's not the form that we want to see. Right? It's like writing 1 as your numerator. You just want to clean that up a little. Line 4. Oh boy. I want those tough. Well, is it a horizontal or vertical line? No. So we know we're going to have something as y is equal to something x. What does our y-intercept look like there?
It's like in
Yeah, so we have to do our best to guess.
6.5.
So -2, -4,
Just say 7.
-6.
6.5.
Negative
6.6.
Negative 6.4.
So I'm gonna say -6.5,
6.7.
which is 13 over 2.
13 of what?
It's 7. Okay, we'll leave it as
6.5.
6.7.
6.5.
6.5.
Matt, you must be mad.
6.5,
Yeah, 6.5.
which is equal to 13 over 2,
Negative, so.
right? It's negative.
The slope.
What's the slope?
-2 over 3.
Well, here I'm gonna choose this point and this point.
How do you know which points to choose?
You just choose whatever you can see. Like,
You choose, well, yeah, whichever one your line crosses like a perfect integer, like perfect coordinates with integers in them, so that we can easily count up and down, left and right.
Oh,
Okay.
it doesn't really matter where you put them unless.
No, except for this one, on this line, there's only really 2 places that really kind of cross it.
Can you go one more up?
Well, this one doesn't cross, this one doesn't quite hit the double right here.
Alright.
It doesn't quite hit right in the middle.
That was good.
Okay. So here we're gonna go down 2, so -2 over 3. Okay, so we're given a line, not so bad to come up with that equation. Yes,
Why can't you do the other one?
I could.
You just
So if I
switch
go
the negative signs around.
up,
2 over
so I'll go up, it's positive or negative for the rise.
positive.
And if I'm going left, 3 is a positive or negative. So it still gives me -2/3. Okay. So one thing that I want to try to get you to start thinking right now, I know you had this question way back in the first unit. Is it -1? Oh, sorry, is it -2 or is it -3? You're trying to treat your fractions as 2 separate things. Try to start thinking your fraction as an entity. So really here's this -2/3. Right? The fraction is just negative. Whoa, easy.
Why are you packing up, guys?
What are you packing up for? I got 2 minutes.
Not that.
I could accomplish so much in 2 minutes. So this one, hopefully you have enough information to fill in the blanks yourself. So slope of a horizontal line is,
Well, would that just be y equals?
well, what's the slope of a horizontal line?
0.
The slope of a horizontal line is 0, right? The slope of a vertical line is undefined. A horizontal line is written in the form y is equal to b, where b is the
Y-intercept.
I found a typo. Vertical line has horizontal line. The slope of a horizontal line is undefined.
yes. Thank you.
Oh, snipes.
So a horizontal line that passes through the point 3, 5. Are we given the y-intercept here?
Yes.
We are.
No, not at all.
3, 5 is not the y-intercept, right? Y-intercept is when x is equal to 0. But here we know that the value is 5. Y is 5. In other words, a horizontal line, y has the same value no matter what x is. So here it says y is equal to 5. So here vertical lines were in the form of y of x is equal to a, where a is the x value. So a vertical line that passes at a point 4, 2, so 4, -2, x is equal to what? 4, just our x value. Right? It's got vertical line that goes x equals 4. The equation is x equals 4. Okay, so do that for homework. Oh, easy. Basically finish your sheet for homework. Plus the homework questions for the test. Okay?